Hello everyone. Today I'm presenting a paper, How Developers Optimize Virtual Reality Applications, a study of optimization commits in open source Unity projects. It's a collaborative project of University of Texas at San Antonio, University of Michigan at Dearborn, and Shanghai Jiao Tong University. The study is motivated by the fact that VR software becomes more and more popular nowadays. And performance optimization is very important due to limited computation power of virtual reality devices. Virtual reality software focuses on frame rendering, so its performance optimizations are very different from traditional software. On the right-hand side, we can see here is the frame lifecycle of a virtual reality software. So usually, before a thing is initialized, a sequence of methods such as wake, and after that, for each frame, a long sequence of methods are going to be invoked, from the physical update to the input, which handles user interactions, to the logic update, which handles the data stored on the VR objects, and at the end, the rendering, which shows all the virtual reality objects. Because the virtual reality software runs many frames per second, usually it's 30 FPS frame per second, or 60 FPS. So it's very important to make sure that all of these methods invoked within a frame is efficient enough. We asked these 6 research questions. The first one is, what are the major categories of performance optimizations in VR software? The second one is, which life cycle phases of VR software are more affected by performance issues? So basically, these performance optimizations, whether they are fixing which life cycle phases in this frame life cycle. And question number 3: how complicated are performance optimization in virtual reality software projects? Question 4 is about whether these optimizations may affect other aspects of software quality. And the question 5, we are going to talk about find out how many performance optimizations are systematic changes. So, which means you're applying the same change in a lot of different places in the code. And finally, we want to find out whether the organizational and the personal projects, basically the large-scale VR software projects and the small-scale VR software projects are different in performing performance optimizations. So then I'll give an overview of our study. So we performed keyword search on 100 top Unity projects, and we find 609 potential performance optimizations based on the keyword search. And we manually go through all of these optimizations, these potential optimizations, and we confirmed 183 performance optimizations. First of all, on the categorization part, so we find that majority of VR performance optimizations consist of these 5 categories. The first one is graphics simplification, which means that you are trying to use a simplified 3D model or graphics asset to replace our complicated ones. The second one is rendering optimization, which means that you're trying to use a more optimized configuration. For example, you're setting the the lighting area of the thing. And API language optimization, which means that you are using a more efficient API, and heap avoidance, which means that you're trying to avoid heap allocation in each frame, within the frame. And finally, the catching values means that you are trying to catch the intermediate results so that you can use them later. So among these 5 most common categories, actually, number 1, the graphics simplification, number 2, rendering optimization, and number 3, heap avoidance are rarely observed in prior studies on non-virtual reality software. So here we give 2 examples, code samples about the rendering optimization heap avoidance. So from the top left code sample, we can see that the developers removed 2 objects, and they are combine these 2 to create our combined mesh, because the VR engine does not need to render them one by one, but they can render them together. And on the bottom right, we can see this is a code sample for heap avoidance, where you can see that the developers remove this new vector 3, which is the instantiation of an object, and then during each frame they're just assigning values to the fields instead of creating a new vector 3. For the research question number 2, we found that for all the life cycle phases, the logic update and before thing phases are mostly affected by performance optimizations. And for research question number 3, we found that actually the majority of virtual reality optimizations need only very small modifications on local files. So even some optimizations involve more files, they are actually mostly consist of repetitive, smaller changes. So to answer question number 4, we are actually checking whether these VR performance optimizations are affecting other quality aspects of software, and we found that there are 2 major effects on other software quality. So the first one is the visual effect, which means that they downgrade the visual resolution, or the visual quality to enhance performance. And for the other part is actually mainly the design aspect. We also find that systematic changes are very common among most of the types of VR performance optimizations. So finally, we started the difference between organizational projects and personal projects on performance optimizations. We can see that there are big mismatch. So for example, the heap avoidance is very common in organization projects, actually ranked number 1, but it's very rare in personal projects. So we can also observe similar difference in the effects. So we can see that for organizational projects, the visual effect happened in only 22% of all the optimizations, where for personal projects its proportion is 37%. So finally, I'm going to summarize the lessons learned from our study. We found that understanding the performance of shader scripts and 3D models is very important. So a lot of performance optimizations are performed by replacing shader scripts and replacing 3D models to enhance their rendering efficiency. And the second one is the developers should learn more rendering optimization opportunities. Finally, the novel VR developers should know that they should avoid heap allocations for each frame. And for the software engineering researchers, we believe that it's very important to find out how to do a precise cost estimation for game objects. And the second one is the user sensitivity of graphic downgrades is very important, because we find a lot of developers they're reducing the visual quality to enhance the efficiency. Also, we believe that there should be some tools to recommend rendering settings and configurations to enhance rendering optimization, and also some automatic heap allocation reduction tools, or some automatic tools to perform systematic changes. Okay, so thanks for your attendance. Any questions?
Hello again. Welcome to the last Q&A session of the defect prediction session. The paper that we are gonna cover today is how developers optimize virtual reality applications, a study of optimization commits in open source Unity projects. And Xiaoyin is here to answer your questions. So thank you for joining. We are looking forward to see your questions in the chat board. In the meantime, maybe I can start with one question.
Sure, thanks.
So it seems there was a lot of manual work in classifying commits, whether they are optimization commits or not. And could you please explain a little bit how you did that? I guess it was a collaborative work. Probably all authors joined. So how did you do that?
Okay. Yeah. So actually, the manual process of the bug reports are performed by like two authors, basically the first author and second author, and then they are creating the results, and then I'm the one who is going to kind of like they are doing that separately, independently, and then when the results are coming and there are some conflicts. And then when there's any conflicts, we are doing a resolution, and I'm doing a resolution to check any differences. And for some of the cases, I may ask both of them to also perform a so we discussed, for example, sometimes it's not simple. It cannot be simply resolved as I'm agree with one of them. Sometimes we may need to create a new type of bugs, like a new new category. Because this is something that we don't think it belongs to either. For example, one of them is like categorize them as the bug to A, and the other one is categorizing it to B. But later we discuss it and find it is not either. It's neither A nor B. So we want to create a new category. Yeah, we're also doing that in the discussion process. Yeah.
Yeah.
Thanks.
And so you mentioned in the paper also that. For example, you did a keyword search on the commits to identify whether they were performance optimization commits or not. But you mentioned that you found some code changes commits which are both optimization and something else.
Yeah.
So did you include those into the study, or how did you make the elimination?
I see. Yeah. So we're doing a keyword search. We are using the prior earlier work, like they have proposed a number of keywords, and we are searching those keywords, and also we are adding some keywords that are specific for virtual reality and basically the rendering, for example, like FPS, those kind of keywords. And after that, we found those like commits. So for these commits, we are manually identify which part. Some of these bugs. Or like commits, they actually not really bugs. Sorry, some of these commits they have like part of the changes they're actually doing the performance optimization, part of the changes are not. And actually, both of the students they are actually selecting only. They also doing the work on choosing the part that is actually optimization related, and we only work on those changes. So basically, it's a line based. So for example, these lines are actually optimization. Well, if there's something unrelated, then we don't consider those. But if there's some cases like, for example, when you're doing the optimization, you're moving the fields from one place to another, and sometimes you also need to change the references. And for those cases, we also consider those dependencies.
Yeah.
So if it's dependent on the actual optimization. Yeah.
Yeah, and it's quite difficult to really isolate.
Yeah. So we're actually doing only. I think I forgot the really number, but I think it's it's just like a small number of bugs. I think 200.
Yeah.
Less than 200. Yeah.
Yeah, and I also have another question. So far, we didn't get any. So you in the first question you were the research questions. You looked at the major categories. So the categories are really simplifying graphics, optimizing rendering, API language, and stuff like that. And then in the lessons learned part, you also mention about cost estimation. So how can you discuss a bit more on this? Do you mean developing a VR project and its cost estimation should be done considering these optimizations? Why? So I couldn't find the link between the cost estimation lesson.
I see.
the main
Yeah,
optimization.
thanks. That's a great question. So, yeah, this may be related to the limited size of the the slide and the 10 minutes video. Yeah. So the major issue is between the we are actually having one of the major perform optimizations is the rendering. And in the rendering, we need to know in VR software, when they are rendering objects, it depends. So the cost of each different object is different. So for example, if it is rendering a dog, and this dog may have a lot of animations, and it may has a lot of the polygons. And the more the more detail you have on this dog, and the more costly it is going to be when rendering. But in reality, we found a lot of developers, they are changing for example, resolution or changing the models, simplifying the models to make the rendering cost lower. So we are thinking the lessons learned, we're thinking that it will be great if there are more a better estimation, rendering cost estimation tools that can find out how a model will cost at rendering, so that they can in advance to use a better model instead of afterward when they find there's a problem issue, they are going to change the model.
Yeah, I get it. Thanks.
Yeah, I'm sorry. Yeah, there's a kind of a missed connection there.
Yeah. It was just for me, probably. So we have a question from Guru. They congratulate your work. Do you also rank the commit on the basis of keywords to prioritize them? Do you face false positives as a problem in your study?
Yeah, that's a great question. Thanks, Guru. Yeah, we are actually because we only got 500 or so bug optimization messages, commit messages in our work. We are using relatively, I would say, small number of keywords that are used in prior works. So we are not really prioritizing them, but we are actually going over everything. So all the 500, but we are for some of them, like the 300 or so, they are we decided them to be not performance optimization. So they are ruled out earlier before we are actually performing any manual analysis on the code level. So we do have the false positives, but it's during the study we are ruling out using the manual process. Yeah. Thanks for the question.
So do you remember what was the percentage of those false positives, or did you measure any kind of how many of them were...
You mean the false positives?
Yeah.
Yeah, we have the 2 students to work on the to go through the 500 bugs, the commit messages first, and then there are going to be some conflicts also, and then I'm also going to be the judge to find out whether it's actually optimization or not when there's any conflicts. So it's the same process, but it's earlier. It's the first. It's before we are doing any a code level analysis for the commits. We are first deciding the scope.
Yeah. Do you think you can automate that part, because it's really manual work? Is there a way to?
Yeah.
Just
I believe so. I believe there's after we find all of these characteristics of these optimizations, I believe there may be ways, for example, using learning-based approach to enhance this approach. But however, this is because this is a study, more of a study part. So we want to make sure that our results are kind of precise enough. But in reality, if we want to locate these performance optimizations, I believe we can use learning-based approach based on the characteristics we found in this paper.
Yeah, and then we can replicate this.
Yeah, that's right.
Applications. Thank you very much. If there are any more questions, we can proceed. But so far, it looks like this is it. Thank you very much for joining. And if the attendees are interested in talking more, they can move to the discussion room together with you. Thank you.
Okay, thanks.